Good morning. My name is Pranavi, and my topic is knowledge distillation in deep neural network training. Why knowledge distillation? Large deep learning models like GPT-3 with its 175 billion parameters offer impressive performance but come with significant computational and memory demands. This makes their deployment challenging on prevalent resource limited, like devices such as mobile phones, IoT sensors, and edge computing units. While smaller models are more efficient, they often struggle to achieve comparable accuracy without some of the form of guidance. Right, and knowledge distillation is elegantly addresses this by enabling smaller models to mimic the superior performance of their larger counterparts. And it has divided into it has features like efficiency, performance, scalability, and accessibility. And teacher student framework. The core of knowledge distillation lies in its teacher student architecture. This framework facilitates efficient knowledge transfer, the teacher model. Well, let's talk about the teacher model first. A large complex neural network that is already highly accurate and well trained on the target task, and it act as a source of knowledge. And when it comes to the student model, it is a smaller and faster, but it's a lightweight model designed for efficient deployment. And its main aim to learn from the teachers, non nonsense, nost outputs. Its main aim to learn it from the teacher model. And the soft targets are the student learn by mimicking the teacher's probability and the distribution, which is the soft targets rather than just the hard labels, example, cat or dog. Types of knowledge transfer. Like let me say knowledge distillation can also involve transferring various forms of information from teachers to student model or either and also each offering the unique benefits of it. Like let's say some benefits of it. Response based distillation. In this, this is the most common method. Whether student learns from the teacher's soft output probabilities like logits. This provides richer information than just the final hard. This labels reveal class similarities and confidences. Let's continue. Response-based distillation. This is the most common method where the student learns from the teacher's soft output, and these provide richer information than just the final hard labels. And the revealing class similarities and confidences. Next, another benefit, my unique benefit are feature-based distillation, which is nothing but the student aims to replicate the immediate layer activations of the teacher. This helps the student to learn useful representation, useful patterns, and useful insights, and features extracted by the teachers, improving its internal understanding. The next one is the relational-based distillation. This advanced technique focuses on the transferring the relationship between the neurons and features or like features within the teacher model. It captures the structural knowledge and dependencies learned by the teacher and its complexity architecture too. Next topic is some mathematical intuition. At the heart of knowledge distillation lies in the concept of softmax with temperature, which is the mathematical adjustment that helps in extracting more non non nonsense information from the teacher model output. Softmax is one of the typical and it is used to convert raw scores into probabilities. And it introducing a temperature, like we call it as T into softmax function. It softens the output of probabilities, making them less peaky and more informative. A higher T value results in a smoother probability distribution in revealing richer information about class similarities and uncertainties that standard softmax might hide. The soft model is trained to minimize the entropy loss between the two outputs, like zone outputs, and the teachers often outputs are efficiently learning these subtle relationships. And this is a this is a formula for the mathematical institution. Pi is equals to e power zi by t, sigma I e power z j by t, where z I are the logarithm and t is a temperature parameter and t to in infinity, these are the probabilities to approach a uniform distribution. While as T to zero, like which while T temperature to zero, they approach a hot encoding. Training process overview. The knowledge distillation training process is systematic and follows distinct steps to ensure effective knowledge transfer. First step is the teacher model training. First, a large, powerful teacher model is fully trained on the original extensive dataset until it achieves high accuracy. This model serves as the expert source. And the second step is soft label generation. The trained teacher model then process a new potentially small transfer dataset, which can be the original training set or a subset to generate soft labels and if probability distribution for each input. These are the rich insights the student will learn from. Step number three is a student model training. Finally, the smaller student model is trained. Its loss function combines with two components. One is the cross entropy loss against the teacher soft labels, and the other one is a standard cross entropy. It's two labels like cross entropy and standard cross entropy. In this standard cross entropy will loss against the hard, which is true labels of the data, and this dual loss guides the student to mimic whether the teacher generalization ability while retaining its accuracy on the ground. This process ultimately leads to the significant benefits: faster interference times, reduced memory footprint, and enhanced suitability for edge deployment. Applications of knowledge distillation. Knowledge distillation has practical applications across various AI domains, making advanced capabilities accessible on diverse platforms. And let's say mobile AI, enabling on device speech recognition, real-time image classification, NLP, directly on smartphones without cloud reliance. And the second one is autonomous systems, deploying complex perception and decision making models on autonomous drones, robots, and self driving vehicles with limited onboard computing resources. The third one is the NLP, which is natural language processing, compressing massive uh, language models, which are LLMs, into smaller deployable version while retaining much of their original performance. For example, Stanford's Applica model was distilled from the OpenAI GPT-3, offering similar capabilities at the fraction of the cost. These are the applications of the knowledge distillation. Benefits of limitation. Sorry, benefits and limitations. When it comes to the benefits, reduced model size significantly shrinks the footprint of deep neural networks, and it has a faster interference which allows the models to process data more quickly and it saves times. It works on the real time. Improved generalization. Student models can sometimes generalize better than the trained from limitations. Accuracy gap. The student model may not fully match teachers' peak accuracy, especially on complex tasks. Tuning and the limitation is tuning complexity, teacher dependency, and ongoing research. These are the recent advances and trends in the field of knowledge distillation is a dynamic with continuous innovation pushing its boundaries, which is simplified distillation methods, online distillation, distillation of novel architecture. And these are the advances that underscore the growing importance of knowledge distillation in tiny machine learning movement and border edge ecosystem partially vital for emerging tech hubs like India. And online distillation, which is nothing but a paradigm shift where the teacher and student models are trained simultaneously, often leads to the more robust efficient learning. And it comes to the distillation for novel architecture, its application is expanding beyond the traditional CNN to more complex architecture like graph neural networks and transformer addressing new challenges. This is a whole summary of the knowledge distillation, which is used in the practical AI, democratism, balanced performance, innovation catalyst, etc. These are the bridge gap between the cutting edge research and practical application knowledge distillation is shaping the future. This shape the future of AI. Thank you.